Welcome back, everyone. So in this video, we're going to go through a practice problem for resistors in series, right? Well, we've got our setup here. Here's our circuit, R1, R2, R3 in series, right? Just one loop. We have our values. The source of the battery, 15 volts. R1 is 10 ohms. R2 is 20 ohms. R3 is 30 ohms. Okay, I'm going to ask that we find the total resistance of the circuit. I'm going to ask that we find the current in the circuit, and I'm also going to ask that we find the electric potential drop for each resistor. Okay, so just for space, I'm going to erase the picture and the questions, but I'm going to leave the numbers. Okay. All right. For part A, we asked to find the total resistance. Well, how do we find the total resistance of a series circuit? Well, we go to our equation. R total equals R1 plus R2 plus R3. Okay? We know we only need to go up to R3 because there's only 3 resistors. All right, we plug in our values. 10 ohms plus 20 ohms plus 30 ohms equals, well, 10 plus 20 plus 30 is 60. And of course, we cannot forget our units, 60 ohms. Sweet. That was part A. How about part B? I want to find the total current. Well, I have voltage. I have a resistance. Let's use Ohm's law. R equals V over I, which will convert to I equals V over R. 15 volts divided by 60 ohms equals, well, 15 over 60 is 1/4. 1/4 is 0.25 amps. Okay? Pretty simple. And finally, part C, we wanted the electric potential difference for each resistor. So what we've got to do is set up a V equals IR for each resistor. Okay. Now, we're looking for V. We know the resistance of each resistor, 10, 20, 30. All right, so then what do we do for our current? Well, this is a series circuit. Every single resistor has the same current. So let's do this. Okay, 0.25 amps times 10 ohms. Okay, just give me a little bit more space for separation. 0.25 amps times 20 ohms. 0.25 amps times 30 ohms. Alrighty. Well, we have 0.25 times 10, which is 2.5 volts. Great. 0.25 times 20 will be 5 volts. 0.25 times 30 is 7.5 volts. Okay, so as that circuit went through, the 10 ohm resistor dropped 2.5 volts of electric potential difference, which left 12.5 left to go. The 20 ohm resistor dropped 5, which only left 7.5 left to go. That's how this works, right? So 2.5 plus 5 plus 7.5 is our original 15, which is exactly what we wanted in the first place, right? So it works. It's good. Now, typically, a question regarding series circuits doesn't ask you to do this much. They might ask you something a little bit more specific and only maybe one thing at a time, maybe two, maybe. So let's see. Let's say we have 3 resistors in series. Okay, we know this is a 30 volt source, and we know the electric potential difference from this resistor is, let's say, 15 volts. The electric potential difference from this resistor is maybe 8 volts, what is the electric potential difference of this resistor? Well, using Kirchhoff's loop rule, where as the current flows through the circuit, after it passes the last resistor, all of the voltages must add up to the source, which in this case is 30. So we have 15 volts plus 8 volts, that's 23 volts. 30 minus 23 volts tells you that this is 7 volts. Right? That's a common question. Another one you might see. I'll only make this 2 resistors just for time. Okay. Maybe they'll say that the current, we'll call this R1 and R2. Maybe they say the current for R1 is 3 amps. What is the current through the second resistor, R2? Well, this is a series circuit. Remember that the current in each resistor stays the same. So this is also 3 amps. Right? So it's this different kind of stuff that they could ask you. They could ask you, okay, well, if we know the resistor, if we know the current in the circuit and we know the voltage and we know one resistor, we should be able to figure out the other resistor, right? You just kind of do a reverse of that first problem we did here in this video. Right? So there's a lot of different ways you can approach this question, all kind of stemming off of this basic idea of the 3 that we saw. We have the long one where they're asking something specific about a specific resistor for voltage, and another one for the current. Okay? So that's pretty much all I've got to go over with this here today. I'll see you next time.